So finally, with the Claisen condensation is you can have synthesis, and it's very similar to what we did with the aldol condensation or reaction addition. So the first thing you need to, so this might be given to you and you will be asked, how did you make this? And you will not be told whether this was Claisen or aldol addition condensation. So you have to determine that. Now it's easy to tell if it's a Claisen condensation. It's a very simple thing is you have this ester group. So what you have here is you have the beta keto ester. So we have a ketone and we have an ester. So this must have come from the Claisen condensation. Okay, so therefore you have to determine your alpha hydrogen, whereas your beta, and then just cleave or cut that bond in half and then go from there. So this is our alpha. This is our beta. Why is this our beta? Because we don't have an ester group attached, so it must have left. Okay, it was a carbonyl. So you cut this in half from here, and then what you do is you attach an OET group, an ester group. OCH2CH3 is the same thing as OET. Okay, and now, so because this was, remember, this was the enolate. And now we draw the product, sorry, the original OET plus CH2 OCH2CH3. So I'm gonna number them for you. This was the beta and this was the alpha. So you were able to go back and determine how the reaction took place. Okay, so what are the steps? The steps is start counting from the ester. You always count from the ester. So I told you this was your alpha. So here it is, alpha. And then you find the beta. That's the next carbon, the carbonyl in this case. You break the alpha beta bond as we did. You add OET to the ethoxy group to the beta position. And then, of course, you put a negative charge on the alpha position as we did right there. Okay, so let's see if we can do the next problem. So maybe you should, again, pause the same thing and determine if you can do it. And I can give you a hint on this. This is a cyclic reaction. So this is all in one compound. It's not two separate ones. So you might want to pause and go through the exercise that I showed you. And well, you'll check when you play my video. So you should pause now. Okay, so we're going to go through the same exercise. Count from the ester. So this is alpha right here. This is the beta. So I cut this in half. And then what I do is I add an OET to it. Right there. Okay, so let's see how that looks like. So I'm going to start from the top. Okay, so Here's my beta. Just continue. Continue now. So we go here. Now that's there. Down this way. And now these are no longer attached. So you should be able to continue. So then we're right here. Then that. Okay, so I'm going to number them for you so you can see it. So no need to worry. Okay. Here's our alpha. Here's our beta carbon. And let's actually do some numbering here. Let's call this 1, 2, 3, 4, and 5. That's this carbon. So here we go. 1, 2, 3, 4, and 5. Okay, so this is an intramolecular, meaning reacting with itself or within, Claisen condensation. There's usually a name for it. Your book calls it, it is actually the right name, the Dickman condensation. Now here's, let me tell you a quick hint for this. If you formed a 5-membered ring, then that came from 6 carbons in total. So if you count 1, 2, 3, 4, 5, and then that would be the 6th. If you form a 6-membered ring, then that comes from 7 carbon atoms in total. Okay, so for this, we'll stop here, and then next week we'll do the Michael addition and amines.